function generator and oscilloscope. Yeah. Function generator, of course, it generates functions, sine function, square function, yeah, triangular function, yeah, house functions. You can also generate arbitrary functions, which means you have to submit a waveform to it. Okay. Let's go back to the sine wave. What can you do with the sine wave? You can set frequencies right here. Yeah. I can punch in the number 1. Again, I can select megahertz, kilohertz, or self. I select kilohertz, so this is 1 kilohertz. Yeah. I can also set the amplitude. Yeah. I can punch in the number 10. What does VPP means?
Peak to peak.
So a 10 volt peak to peak means the sine wave should go from
5 to negative
5 to negative 5, right? So that's what we have here, yeah? Okay, good. Then the next thing is I'm going to put this onto the scope, yeah? 4 channels on the scope. I'm going to use the first one, okay? 2 channels on the function generator. I'm going to use channel 1. Channel 1, yeah? Is that okay? Yes?
Yeah.
The probe here has
Negative
and positive. This also has a and how do you make the connections? Okay, so you go negative, negative, yeah, and positive too. So this was done in this way, right? Is this correct?
Yeah.
Hopefully.
Isn't there a rubber piece on that?
Yeah, don't you have to like pull it back and then put it
This
onto
is
the metal
a
insulator?
insulator. This is a plastic.
Right.
Yeah.
So you have to pull
There's
it back.
no connection here.
Just follow what they were doing. Follow what they were doing.
Yeah.
Huh?
Yeah, look at them.
I came in here.
Engineer.
Yeah.
I had it, but it kept
This
slipping
is
off.
a damn plastic. This is not a conductor. This is an insulator. Engineer.
Isn't everything a conductor? The
Huh?
voltage is high enough?
No. We don't have 10,000 volts here, so forget it.
Why not?
Understand? How do you make a connection? Take the conductor out,
You see how bent it is?
and now you have a connection. Understand?
It's like freaking
I did say that. No.
Oh.
Now, but then I still don't see anything on the oscilloscope, right? See, I don't see anything though. And what you see is actually this. Whoa, look at that. I mean,
That's my brain after a
this is
semiconductor.
some nice waveform. You can see, wow.
That's the chance class. My life.
Look at that. Wow, I think
I'm done.
Isn't this fun?
Okay.
And look at that. That's what you see though. What the heck is that?
Noise.
Noise.
Huh? What the heck? Look at the amplitude of this guy. What is it? 1 millivolt. What does this tell you?
Very tiny.
It's basically noise. Noise typically has very, very small amplitude, and you see them in 1 millivolt, right? I mean, don't this look like noise?
Yeah.
Yeah?
Yeah.
So I'm not getting anything from the function generator. What is wrong there?
Your function generator is not on.
It's not on yet, right? You've got to turn it on. So because I have not turned it on, this guy is only picking up the noise.
Okay.
Okay? So I'm going to turn it on now, and now I start to see some stuff. Yeah? So then I can control it and start to make some lines. Yeah. And now you see the sine wave that you want to
Ooh, that's
see.
fuego.
Right? Yeah? Yes or no? Okay, good. Now, first thing you need to learn how to read the scope is that number. What is that number? 200 microseconds, which is equals to 0.2 milliseconds. What does the 0.2 millisecond mean?
That's
How long it takes to
the,
one cycle? Yeah.
What?
I'll do.
What does the 0.2 millisecond mean?
isn't that the scale, the ticks that you're zoomed in on?
What does the 0.2 millisecond mean?
Is it the
No, 0.2 millisecond is not frequency. What is 0.2 milliseconds?
time it takes to
Period? What should be the period of 1 kilohertz? 1 millisecond, right? Yes, that is 0.2 millisecond a period. No. What does the 0.2 millisecond means? Do you see the horizontal division here?
Yeah.
One division is 0.2 milliseconds.
Oh.
Yeah?
Yeah.
Is that okay?
Yeah.
Yes or no?
Yeah.
And is this one period?
Yes. Yes.
How many divisions are there in one period?
5.
5 times 0.2 milliseconds gave you
One.
1 millisecond. Exactly what you want, right? Yes or no?
Yes.
I can change the scale. How many periods do you see now?
1.
How many divisions? 10 times 0.1 milliseconds also gives you 1 millisecond, right? Yes or no? Okay. So you can now. If I make the scale to be too small, see, it's very small now. What do you see? A straight line. Why?
Yes.
Because I'm only looking at a little tiny portion of the sine wave, right? Yes?
Yeah.
If I make the scale to be too big, what happens as the scale gets bigger and bigger? You see more periods, more periods, more periods, more periods, more periods. Now this is a lot of periods, right? Yes or no? Okay? Okay. Now, the other thing you need to learn is the 5 volts. What does the 5 volt mean?
VP. Peak.
voltage at the peak?
Yeah.
No.
From origin.
Yeah.
No.
From top to
No.
oh,
thing,
yeah,
the
right,
thing,
right.
this thing.
Just like the time, do you see the vertical divisions?
Right,
Yes.
right.
One division is 5 volts.
Okay.
Okay? So this sine wave should go from negative 10 to 10. This on the function generator is going from negative 5 to 5. This one go from where?
Negative
10 to 10. This one go from?
Negative 5.
Why don't they match when I have a direct connections between the two?
Because the multi-sim had this is because they're going from negative to negative. So
Why don't they match? See, I'm making a direct connections between this and this, right? See? Direct connection, yes or no? But why don't they match?
You're only using one channel on the function generator?
uh,
Let me reduce this. Let's go to 5 now. What do you see on the function generator?
2.5.
Negative 2.5 to 2.5 here.
5.
Negative
5 to 5. It seems like this guy is half. Why? Where the other half go? You see the black hole there of the
Magic.
Yeah. So the other half goes to the black hole there. Why?
Is it divided like it was for the time?
Why? Where did the other half go? What's the lesson here? Young engineers like you tend to do what? Take things for granted. What do I mean by take things for granted? Whatever you set on here, you think you take it for granted that it's going to come here. It's not. It's not. See? Don't never take things for granted. You need to understand why is where the half goes. You need to understand why. Don't take things for granted. Always verify something, right? I mean, I have a straight connection. See, whatever output coming from here should be on here, right? But I'm not seeing it, even with a direct connections. Never take things for granted. Engineer, always remember that. Okay. Very easy way to solve this. Yeah, I press the sign, press the output menu, okay, press the load impedance. Yeah, right now it's on load. We can fix it by pressing the high Z,
Okay, that's fine.
and now go back to the main menu.
Oh, there you go. Now it matches.
Yes. Yes or no? Yes or no?
Yes.
Okay, so what was going on previously? So previously it was at what? Load, right? Yeah? Can somebody give me a paper and a pencil, please? Yeah, I have it. Thank you.
So,
So very simple stuff. I have a source, right? I'm just going to draw a AC source. Yes or no?
Yes.
Can somebody read the, the number here?
50 ohms.
50 ohm, yeah? That 50 ohm is the output impedance of this source. So this is the 50 ohm from here. Okay? And now what is the load?
50
50 ohms. And this is your 50 ohm load, right? And the output is at the 50 ohm load. And then the input is here, right? Simple 3004 material. What is output in terms of input?
50.
Output is half of input. Exactly why it is half. Do you understand why it was only half? Yes or no? See? Simple 3004 material, right? Yeah? Now, we fix it by doing what?
Increase it higher.
Pressing high Z, yes?
Yeah.
Now, if I put high Z, what does it mean now if it's high Z? What is high Z? High impedance? High impedance is equivalent to
A short. Well, not a short. Open.
open circuit. And now what should V out be? Same as Vs. That's how we solve the problem, right? Yes or no? Simple 3004 material.
I think I'm gonna have to take your class again.
You gotta take 3004.
I'm
Man.
gonna fucking take that class again.
Yeah, so simple, right? You see the things you learned is here, here, here.
You should get Shannon to sign that.
Huh?
Sell it.
Sign it. Hang it up on your.
Yeah. And then sometimes when you see something like that, yeah, and what the heck is that?
What is the sign was?
What did I just do?
You disconnected the negative to the negative.
So what happened?
It's not constant.
You don't have it completed.
So what he is saying is, hey, I don't have a reference point. He's saying, where's the reference? 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 That's why he gave you a range of values. You understand? Because he doesn't see a reference ground. Understand?
Yeah.
Okay, so let's put back the ground. And now we should be good. Yeah? Okay. Another thing is, what is that? And then good. And then not good. What is that? And then good. And then not good. What is that?
Yeah, he's changing the amplitude. Which one is he?
How long did it take for me to mess things up?
Nanosecond.
Twist of a knob.
Twist or not, right? Okay, you see I can mess things up just like that, right? Yes? What does it tell you? You got to be very worried about me walking around the lab. Because the moment you turn your head away, right? I can just sneak in and mess your thing up. And then I will walk away pretending that I did not do anything. And then I will leave you dry so that you would be forced to learn learn how to troubleshoot things, understand things, and recover it. That's how I force my students to learn. So from now on, yeah, whenever I'm walking around the lab,
Cover your workstation.
so just stay alert of where I am. Is that okay? The good news is, of course, after this week, I will not come as regularly I have been doing. I will stop coming very often, so you don't have to worry that much. Is that okay? Now, what is going on? Well,
I mean,
First thing you need to understand, this is a digital oscilloscope. What does digital mean?
It's not analog.
That means things are in what form? Discrete or continuous?
Discrete.
Discrete, right? So what the oscilloscope is doing is showing you points. Boom, 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 boom. Discrete points. How many discrete points can it show? Can somebody read the number? 2.5 giga samples per second, which means what? How many points? 2.5
Times 10 to the 30.
billion
To the
points
2 to the 30.
per second. Is 2.5 billion points per second a lot? Yes or no?
Yes.
Within a second is a lot, right?
Yeah.
Which makes the points very
Close.
close to each other, which makes us think that we are looking
Line.
aligned. See, we humans are being deceived by machines. We think it's a line, but the fact is it's not a line. They are basically points. Who supplied the points to the oscilloscope?
The function generator.
Generator, right? In what manner? Well, the function generator is supplying the points in the continuous manner. You see the green light here? What does continuous manner mean? What does continuous mean? Continuous means this guy, this function generator, is supplying points in a real-time continuous manner. That means it's giving the points all the time, as long as you turn it on, right? Yeah? So in effect, you should see a continuous waveform like that. See? Continuous waveform, right? Yes? But then the catch is this useful? No, for us it's not useful. You know, some students who do not understand this and they carry this ignorance into the next lab. You know what they do to correct it? They see, oh, this thing is running, and then they see a run stop button, and so they go ahead and press it. Does it solve the problem? No. See, you need to know what is going on, right? Pressing it doesn't help. Yeah? So, we don't want this continuous waveform, right? What we want is something stable, like that. Now this is useful for us, right? So then we have to give the scope some instructions to get the stable form. What are the instructions? Well, you have to click the trigger menu right here. See, click the trigger menu, and then you come up with this menu, right? The instructions we are giving is, hey, scope, if you see a positive slope, if you see a value which is anything 0 volt, start showing me the waveform according to the number of cycle I want, and stop. That's the instruction we are giving to the scope. I can change the level to now 2 volts. Yeah, so what is he seeing? He see that, okay, so you guys want a positive slope, yeah? And you also want me to start when I see a 2 volt. So is it 2 volt now?
Yeah.
So then when you see a 2 volt, then it starts showing you the sine wave according to the number of cycle you want. You understand? Yes or no?
Yes.
Okay, so then what happened now? This is at about 6 volts. Why is it doing that?
It's higher than the threshold. that you
Because
set.
he keeps searching for 6 volt. He will never find one. He's trying so damn hard. Doesn't matter how hard he tries. He can try for 100 million years, yet he will still not stop. Do you understand or not? Yes or no?
Yes.
Yes or no? Yes. So to solve it, it's very easy, right? Just put it back, yeah? And now when it sees something it wants,